3B, multi-step equations. Our goal today is to be able to solve multi-step equations involving fractions and decimals. Okay, go ahead and organize your notes. Notice how I've got a line down the middle of the front side here on examples 1, 2, and 3. I'm going to show you two different ways of solving each one of those problems. Just go ahead and pause the video, get your notes ready to go, and then you can push play when you are ready to come back. All right, let's take a look at example number 1. This equation is involving fractions, as you can see. We've got 2/3 and we're adding 3/5 m. This 3/5 is being multiplied to m is equal to 31/15. So you notice how here's our variable, here's our m, and it's connected to 3/5. Remember, we're talking like that's connected, like that's our closest friends. So we'd want to undo the plus 2/3. And obviously the inverse operation would be just minus 2/3. And we have to do that to both sides. I'm going to draw my line down the middle here just to organize my work. All right, so we got 2/3 minus 2/3. That makes 0 over here. And then over here, we're going to have to subtract, and we'll need common denominators. I'm going to drop down the 3/5 m. In fact, I'm going to put 3/5 in front of the m. It's being multiplied. The m could be in the numerator or it could be behind it like this. Now, when we subtract fractions over here, we're going to have common denominators. So we're going to make it 15. That'd be the least common multiple. So this will be 31/15 minus 10/15, which would then give us 21/15. Okay, so now I'm ready for step 2. Okay, so in order to get the m by itself, it's being multiplied by a fraction. We can multiply by the reciprocal. So I'm going to do that to both sides. We know that the 5's will cancel, the 3's cancel. This all becomes 1. When you multiply by a reciprocal, you get 1m. Now over here, we're going to have to simplify before we multiply. A 21 and a 3, we can divide by 3. And then, of course, the 5 and 15, we can divide by 5. And then multiply straight across 7 times 1 and 3 times 1. So we're going to end up getting the value of m as 7/3. That's the value of m that would make the equation true. Okay, we're going to do this again, only I'm going to show you a different way of solving it. I like to show you 2 different ways because one of them might make more sense to you or be easier than the other one. So we're going to do this again. So I'm going to have you write down the equation again. And I'm going to show you a different way of solving the equation. We will go ahead and switch the color here. There, that looks fun. We'll do bright green. Okay. Okay, right over here. Now remember, whatever I do to one side, I have to do to the other side of the equation to maintain balance. Now do you see how the denominators are 3, 5, and 15? I could multiply by a number, every single one of these terms on both sides of the equation, by a number that would allow me to get rid of the denominators or turn the denominators into the number 1. As long as I do this to both sides of the equation, I will maintain balance. Now, if you look at 3, 5, and 15, think about what the least common multiple would be. What would a common denominator be? And you would say 15. So I can multiply this side of the equation by 15, but then I'd have to multiply this entire other side of the equation by 15 as well. Okay, that means this first term and the second term, both terms would have to get multiplied by 15. So I'm just going to pull up my eraser really quick. And I'm going to show you how I'm going to do this here. Okay, so I'm going to multiply this first term by 15. And then this second term right here, I'm going to also multiply that by 15. Okay? Now when I do this, do you see over here on this side? 15 is written as 15 over 1 as a fraction. The 15 and the 15 are going to cancel because both the numerator and denominator are divisible by 15. Then I just end up getting a 31. How nice is that? Okay, got rid of the denominator. Over here, make that a 15 over 1. Now 3 and 15 are both divisible by 3. So when I multiply here, we're going to get 5. So I'm really taking this 2 that's left and multiplying it by the 5. 5. I'm going to multiply it by the 2, giving me 10. Okay, now when I multiply over here, 15 over 1, 15 over 1 times 3m over 5. Do you see how the numerator and denominator are both divisible by 5? I get 1 here and then 3. So now I've got 3, and I'm going to multiply that by 3m. And 3 times 3m is 9m. And I've just made this problem a whole lot easier and got rid of all the denominators. Now if we continue solving, take away the 10 here, I get 9m is equal to 21. And then, of course, we can divide by 9. And we're going to see here that when we divide by 9, we're going to get m is equal to 21 divided by 9. This can be simplified. And we end up with 7/3, which is exactly the same answer that I got over here. I just did the problem a whole different way. Okay, so 2 different ways of solving an equation that has one variable m attached to one of the terms. Okay, that was our example number 1. Let's go ahead to number 2. Now we're going to do this one 2 different ways. So let's start off right over here on the left. Go ahead and write it down one time. Now, do you see the difference with this one is that there's an x here and there's an x here on both terms. In fact, this is an invisible 1x, isn't it? So if there was no denominators at all, pretend like there was no denominator, and we had 3 x's minus 1x. These two are like terms. We would combine them together. Well, it's no different when you have fractions. Okay, so there's an x here and there's an x here. Being that these are like terms, the 3/4 and the invisible 1, 3/4 x minus 1/3 x, we want to combine them together. This is one way of doing this problem. So let's go ahead and combine these two together, but in order to subtract, I have to have a common denominator. So let's make that 12. So we're just going to triple the numerator and denominator here and multiply by 4 here, and we're going to end up with a common denominator. So 3 times 3x, 9x over 12. And then I can't even read my own handwriting. That's times 4. 1x times 4 and over 12. Okay, keep going here. All right, so now do you see we have 9/12 x take away 4/12 x, and we can clearly combine them because they're like terms. 9 take away 4, we have 5x over 12, or 5/12 x. They are the same thing. Okay, so I'm going to get ready for my next step. I'll make this blue. Now, I could do a couple different things. I don't want to confuse you too much in the video here. So this is 5/12 x. Being that this is a fraction connected to the x, I could at this point multiply by the reciprocal. Because then the 12 cancels and the 5 will cancel, and I just get x by itself. Then over here, I'd have to do the same thing. I'm going to multiply by 12/5. Make this a fraction. All right, divide by 5, we get 1. Divide by 5, we get 2. And 2 times 12 is 24. And we get our solution to be 24. So x, if I were to plug back 24 into both of these places where we see x, we would end up with a true equation. Okay, so that's one way of solving this. You saw that I just combined like terms. Okay, so we're going to do this problem a different way. So I'm going to have you take a moment now and just go ahead and rewrite the problem. And let's see if we can show you how to solve it a different way. Okay. So do you remember on the last one, example number 1, we got rid of the denominator. Right now you don't see 10 with a denominator, but I could easily give it a denominator by putting it over a number 1. Now, just like we did problem number 1, what is the least common multiple of the denominators? And you would probably say 12. So what I can do is I can multiply both sides of the equation by 12. Now see what I'm doing here? I'm showing you I'm going to multiply both sides by 12. But when I actually show my work, I'm going to write it just a little bit differently. So multiplying both sides by 12 would look like this. Keep that over 1. I'm going to times this side by 12. And then over here, I'm going to times everything on this side by 12. This term and this term, both of them, okay? So now, 10 times 12, I guess I didn't need to write a denominator, but that's going to be 120, okay? Now over here, 12 over 1, when I'm multiplying the 4 and the 12, we can divide by 4 and get 1. Divide this by 4 and get 3. 3 times 3x's, that's what we have left. would be 9x's. Okay, now here when I multiply by 12, 12 over 1 times x over 3. See how the 3 and the 12 are both divisible by 3. And now I have 4 times x, which would be 4x's. Okay, now I just dropped down the minus sign. I just brought that down here. Okay, now do you still see that these are like terms? So 9x's minus 4x's is 5x's equals 120. And now we end up with just one step left. I'm going to switch colors so you guys can see how I'm getting the same answer, dividing by 5. So I got x is equal to 120 divided by 5. Now, if you take your calculator, 120 is perfectly divisible by 5. It is exactly 24. So we end up with the same answer, two totally different ways. Here we just combine like terms by finding a common denominator, right? Over here, I got rid of the denominators by multiplying by the least common multiple of the denominators, the common denominator. That's kind of what I did. All right, so two different ways of looking at solving an equation when you have each term that has an x. All right, we are ready for example number 3. There you go. Go ahead and take a moment just to write it down. Okay. All right, whenever I do this and I ask kids what would they do first when they saw a problem like this, most students will say distribute. That's like the most common thing I see. They see a number being multiplied by a quantity and they want to distribute. And you absolutely can. In fact, since that's what most kids would want to do, let's do that. Let's make that our first attempt at this problem. So 2/5 times x would just be 2/5 x. And then I need 2/5 times -4, right? Okay, so if I go over here to the side, if I go over here, 2/5 times 4 over 1. See how that's going to give us 8/5? So I'm just going to write 8/5. There we go, there's an 8. Okay. All right, so now you can see that we just have a really nice one-step equation. See how the x is attached to the 2/5? So we're going to undo this by adding 8/5. And over here, we're going to add 8/5. So just solving with fractions. Bring down 2/5. Over here, we need a common denominator. And we're going to go ahead and make that 10. So times 2 times 5. So it looks like we're going to get 5/10 plus 16/10, which will ultimately give us 21/10. So I'm just going to pull that down here as 21/10. Okay, you probably can guess what the next step is going to be. I know you know what the next step is going to be. You have 2/5 times x, so we're going to multiply by the reciprocal. See how handy that comes in? Do it all the time. Okay. All right, cancel, cancel. This is the fun part. Okay, over here, simplify before you multiply. We can divide by 5 here and here. And then we end up multiplying straight across, getting 21, and then the denominator, 2 times 2, I get 4. So we end up with 21/4. Perfectly fine to have an improper fraction. Just leave it just like that. Okay, so that's one way of solving this problem. Probably what most kids would do would be like this is distributive property. All right? So now take a moment to rewrite that problem, and we're going to take a look at it a different way. This is something that not most students think of doing, but it actually is kind of a handy little trick here. Okay, I'm over here on this side. My x is over here, so I'm going to focus on this side, being that that's where the x is. Do you see how the 2/5 is being multiplied by what's in parentheses? This is really multiplication. So when I have a fraction being multiplied by something, I can undo that by multiplying by the reciprocal. So I could times by 5/2 on both sides. Okay, running out of room over there. So we've got the 5s are going to cancel, the 2s are going to cancel. We're going to end up with, this going away. It's just turning into a 1. So the x minus 4 is the only thing left on this side of the equation. Now here I've got, this says, it's hard to read, it's 1/2 times 5/2, and that would be 5/4. Okay, so if I'm going to go plus 4, and we're going to go plus 4 over 1, we'd have to have common denominators, and so that would be multiplying the second fraction by 4, so which would end up with 5/4 plus, if I multiply the top and bottom by 4, that'd be 16/4. Which if you add those two together, you get 21/4, which is exactly the same answer as we got over here. Pretty cool, huh? So this is distributive property, this method. Over here, you just multiply by the reciprocal. That gets rid of everything, and then you're left with just the x minus 4. A lot of times students really like this strategy. They don't see it as quickly, but it absolutely works. All right, so there's number 3. We did it. Okay, moving on, flipping your paper to the back side. Now we're going to take a look at some decimals. We're going to look at strategies for solving equations with decimals, and it's going to be all about making the problem an easier problem. Okay, so take a moment, go ahead and write it down. Now, if we were to solve this equation, you probably would want a calculator. That's typically what kids would need, a calculator, because they just don't want to do the decimal stuff. However, we're going to make this an easier problem. I want you to think, is there some number that you can multiply both sides of this equation by that would eliminate the decimals? You might have guessed it. Yeah, you know that when you multiply by 10 or by 100 or even by 1,000, the decimal points move. One place if you multiply by 10, 2 places if you multiply by 100, and so on. So we're going to use that to our advantage. We're going to multiply both sides of this equation by 10 to get the decimal points to move. So I'm going to multiply this side by 10 and then everything on this side by 10, like this one and this one, both terms by 10. So what that's going to do is the decimal point moves to the right here, and this number becomes 12. The decimal point moves to the right here, and now this number becomes 24. 2.4 times 10 is 24. And then here, when you multiply 0.6 times 10, the decimal point moves and it becomes 6x. So by multiplying everything on both sides by 10, I have just cleared all the decimals and made them whole numbers. So now I can just go at this problem like you normally would. Let's minus the 24. We get negative 12 is equal to, bring down the minus 6x. We're going to divide by negative 6. And over here we're going to divide by negative 6, giving us a value of 2. And we're done. The answer is absolutely 2. So if I were to check this on the calculator, okay, if I wanted to check this, I could plug in right here a 2. I could type in my calculator 2.4 minus 0.6 times 2. And when I type this into the calculator, I would get exactly 1.2. It would work. It would check out. It would be absolutely perfect. My dog is scratching on the door, so I gotta let him in. Oh, somebody got it. Okay, perfect. Sorry about that. Okay, so we could always go back and check our work. Even though we moved the decimal points in the problem, we don't have to do anything with the answer. The answer turns out we just produced an equivalent equation by multiplying everything by 10, and we're good to go. Okay, so that's an example with decimals. Let's go ahead and take a look at another one, number 5. Okay. All right, on this one, go ahead and write it down. Feeling like using some purple right now. All right, now we see decimals again. Let's try to avoid having to use a calculator. Let's use a trick that's going to make this easier problem. What can we multiply both sides of the equation by to get rid of the decimals? If I just multiply by 10, that will work here, but it won't work here. We need the decimal point to move twice. So you're right, we're going to multiply everything on both sides by 100. That will move all the decimal points twice. Watch this, once, twice, but over here, be careful, once, twice. That's going to have to be filled in with a 0. 1.5 times 100 is 150, and then once, twice. So we end up with negative 11x plus 150 is equal to 249. Much easier problem. So then let's go ahead and continue solving. We're going to subtract the 150. And 249 minus 150, now that's going to give us just 99. And then I divide by negative 11. And we end up with negative 9. So much easier. Now there's nothing you have to do. You don't have to to do anything. You don't have to move any decimal points. That is the right answer. That's going to be the answer. So on the calculator, if I typed in this as a -9, so negative 0.11 times -9, and then I went, that's a 9, plus 1.5. If I typed all of that in the calculator, you know what it's going to say? 2.49. It will absolutely work out. So if we were in class, I would have you guys check this with your calculator, and you would be amazed. It works. All right, so we did 2 examples with the decimals as well. Now let's go to our summary. We're just going to quickly summarize here what we did. So let's do this part. Tips for solving equations with fractions. So when we see fractions within the equation, one thing that we did was we multiplied by the common denominator, and that got rid of the fraction. It made the denominator into a 1. Multiply by the common denominator. My handwriting is so bad right now. Oh my gosh, with this thing. Okay, common denominator. That will get rid of the fractions. Perfect. Okay, now tips for solving equations with decimals. What do we do with the decimals? How do we get rid of them? Well, we multiplied by 10, or we multiplied by 100, or if we want to move the decimal point 3 times, we can multiply by 1,000, but we cleared the decimals by using that little trick. Okay, so that's what we did there. All right, so now you should be able to go on and do your practice for lesson 2-3B. All right, good luck, and thank you for watching my video.